one more. We've talked about addition of vectors. We did some examples of it. To me, the simplest way is put it in a rectangular form and add them. But you could also use law of sines, law of cosines, do it that way. I digress. There's also multiplication of vectors. So we need to talk about how to multiply vectors. More specifically, we're going to concentrate on what are known as dot products. There are two different ways of multiplying vectors: dot products and cross products. A dot product, you know you're doing a dot product because the symbol for multiplication is, anyone want to take a shot at it? The other type of multiplication is known as a cross product. You want to figure out what the symbol used for multiplication in this case is? All right. Differences between the two. So this is known as a dot product. It is also known as a scalar product. It's also known as an inner product. This is the last time I'll use that terminology. This is known as a cross product, or a vector product, or someone want to take a shot at it?
Outer product.
Yeah, and it's the last time I'll use that wording in here. I believe inner product and outer product are much more general forms of it, but this something. So it's called a dot product because of the symbol, cross product because of the symbol. It's called a scalar product because the product is a scalar. This is called a vector product because technically no, but yes, as far as we're concerned, yes. It actually produces what's known as a pseudo vector or an axial vector. This is just trivia for as far as we're concerned. For anything that we do, it's going to look, smell, and taste like a vector, so it's still called vector product. It has something to do with reflections. This cross product will show up when we do rotational motion. The dot product will show up more specifically when we deal with work and energy. However, we do need to have a little bit of a background in order to justify the fourth equation over there. So, any questions about this before we dive deeper into dot products?
What exactly does this represent? Is that
What does what?
what exactly does that represent?
Well, this is just math problems.
Okay.
So, in application of it, when dealing with work, work is defined, work deals with a change in energy, work is defined as force times dot product with displacement.
Okay.
Torque is a cross product between the moment arm and force.
Okay, thank you.
All right, so if I have two vectors here, we'll call this A and B, with some angle in between them. I can break either of those vectors up into perpendicular components. I can break any vector up into perpendicular components. So I'm going to break this up into a component. I'm going to break B up so that one of the components is in the direction of A and the other one is perpendicular to it. And we've done breaking up of vectors into its components before. So I have this segment here, which I'll just call B parallel, and the segment over here, which I'll call B perpendicular. So I have these two pieces here. When I do a dot product, I'm multiplying the parallel parts. So I'm going to multiply the B parallel with A. So A dot B is just B parallel times A. Notice the vector symbols are gone here on the right-hand side because it's a scalar product.
Is that B sub 11?
That's the parallel mark. It's parallel.
Oh, okay.
If I did B dot A, it's the same thing. It's the parallel component of, it's the component of B that's parallel to A times A. The magnitude of A. So commutative property holds. That will come in just a moment. So if I have, so if A is 3I hat, I hat, J hat, minus 2J hat, and B is 4I hat plus 1J hat. My dot product is, well, I multiply parallel parts. So A dot B, and so 3I minus 2J, dot product, 4I plus 1J. I can FOIL if I want to. FOIL, this will be the last time I do the full FOIL because, well, so I get 3 times 4, which is 12, I hat dot I hat. Outer plus 3 I hat dot J hat. Minus 8 J hat dot I hat. Minus 2 J hat dot J hat. Obviously, I have vectors here when I don't want any vectors in my answer, so we need to take a next step. But questions up to here before we start getting rid of stuff? All right. Remember that dot product is multiplying parallel components. Well, I hat and J hat are perpendicular to each other. So what is I hat times J hat?
IJ hat?
Nope.
Would they cancel each other out?
Probably not the right wording, but the essence is right. Yes, it's 0. Because they are not, there's nothing parallel between them, that's 0. That's 0. What it amounts to is all I did was I'm multiplying the I components together and I multiplied the J components together. Now, I hat times I hat. They're completely in parallel with each other. Any vector is parallel with itself. So I multiplied the magnitudes of the parts that are parallel. Well, what's the magnitude of a unit vector?
1.
So, I hat is, 1 times 1. So this is just 12 minus, say, J hat minus 2. The answer is 10. Shorthand, I multiply those, add. Here we go. If I have this vector B, so my hypotenuse is a magnitude of, I'm going to put the label B there and use that B to indicate the length, and some angle theta. If I broke it into components, I'd have my horizontal, I'd have that component and that component. This would be B times the cosine of theta, and this would be B times the sine of theta. So over here, if I have an angle theta between them, my B parallel is just B cosine theta. So I can write A dot B as just the magnitude of A times the magnitude of B times the cosine of the angle between them. Given this look, if I did I hat dot I hat, I'd have 1 times 1 times the cosine of 0 degrees. Or radians if you're so inclined. What's the cosine of 0?
Zero.
That would change what we did over there. Cosine of Eva? 1. So I hat, using this definition, is just 1 times 1 times 1, which is just 1, which is what we said over there. I hat dot j hat would be 1 times the cosine of 90 degrees, since they're at a right angle to each other. And the cosine of 90 degrees,
0.
yes. So that's 0. Taking it one step further, or simplifying it, however you want to look at it. If I have any vector dot product with itself, it's the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. Again, if I have any vector and I put it, and it multiply times itself, the angle between them, it's got to be 0 degrees or radians. So this is just a times 1, or a squared. Sometimes you will see this written as a vector squared. If you see that, I think it's bad notation, but not everyone agrees with me. If you see that, you're doing a dot product with itself, and this is what they actually mean. Questions? Because now we're about to get back to that. We got another 15 minutes. You can sit in if you want. It's something you've seen before. So I'm going to take this equation here, vi plus vf over 2 times time. And I'm going to take our definition of acceleration, or vf minus vi over t. And I'm going to multiply these. Since they are vectors I'm multiplying, then I have to either do a dot product or cross product. I'm going to do a dot product. So I have a dot delta x. And over on the right hand side, I have vi plus vf over 2 times time, dot product with vf minus vi over t. Time cancels out. I can multiply both sides by 2 to bring 2 over to here. So I'm left with 2a dot delta x is equal to vi plus vf dot product with vf minus vi. And now we FOIL. So I get vi dot vf minus vi dot vi plus vf dot, did I lose something there? Oh, vf dot vf minus vf dot vi. Obviously, we got some canceling out to do. I have commutative property holds, so I've got negative vf dot vi, and here positive vi dot vf. These will cancel out. I now have a vector doing a dot product with itself, so this vf dot vf is just vf squared, and that's vi squared. So all of that is equal to, so my 2a dot delta x is equal to vf squared minus vi squared. Or putting it in a more traditional form, vf squared is equal to vi squared plus 2a dot delta x. Or s or r, or whatever word you happen to be using. And that's the fourth one. questions to hear? Let's use it. A car starts at is initially going at negative 40 meters per second. It accelerates uniformly for 10 seconds. A little more sophisticated than that. For 7 seconds. What is it travels that one again. The final displacement. Try that again. Final velocity is 30 meters per second. What is its displacement? When solving these constant acceleration problems, there's 5 basic variables. There's displacement, initial velocity, final velocity, acceleration, and time. So my recommendation is just to start out with writing those down. So the x, vi, vf, k, and t. And now, what do we know?
We know that the initial velocity is negative 40 meters per second.
How do you know that's initial velocity and not initial speed?
Because of the units,
Because of the unit?
right?
No, not the unit.
Well, the units to velocity is meters over seconds, so.
So it's speed.
Oh.
It's negative, speed can't be negative.
Yes, speed can't be negative. All right, so I know my initial velocity, done. Now what? What else do we know? We got 2 other pieces of information.
Final velocity at 30 meters per second.
All right, and
Acceleration,
nope, that's not acceleration. That's what is that 7 seconds?
time.
Yeah, time.
Right.
I'm asking what is the displacement? All right, so I've got these 5 ingredients. If I know 3 of them, I can figure out the other 2. There is an exception we'll run into later, but with these type problems, if I know 3, I can find the other 2. I guess I'll say the exception is that if I know initial velocity, final velocity, and acceleration is 0, that I can't figure out the other 2. That's not enough information. All right, so I look over there. So the scatter shot is your mind blanks, you're not quite sure what to do. You can plug those 3 numbers into all the equations and see which equations have only a single unknown, solve for it. Or you can target it. I'm trying to find displacement. I don't know acceleration, so I pick the equation that does not have acceleration in it. Which equation does not have acceleration in it?
Seconds.
And so my displacement, and I recommend on tests and quizzes, start with the equation, write the equation down. And so I get negative 40 plus 30 divided by 2 times 7, which is negative 35
Yes.
units. So I end up 35 meters on the negative side of where I started. If I want to find acceleration now, well, I just need to pick an equation with acceleration since I know displacement. Or based upon what I originally have, what equation has acceleration but does not have displacement? Which one?
Wait, I'm sorry. Just a quick question. Can
Yes.
I just find acceleration from doing the final velocity minus the initial velocity over time?
Yeah,
Okay.
which in essence is the
I don't
first
have-
equation.
Oh, I see.
But that's fine, you can go straight back to the definition, there's nothing wrong with that. So acceleration is 30 minus negative 40 divided by 7, which is 10 meters per second squared.
Can you scoot over a little?
Oh. Is this acceptable? Questions? Same game, no problem. The ball is thrown in the air. At an initial speed of 30 meters per second, so just shy of 65 miles an hour. That's a 30.